warahmatullahi wabarakatuh, and hi everyone. We are from class AS2713D11. Today, we will present about analog versus digital system in daily life for the code PHY528. Next, I would like to introduce our group members. Our group consists of 6 members, which are Nurul Najma Atira binti Suhaimi, Radautu Shakira binti Muhammad Sahabuddin, Nur Faridatul Azna binti Ismail, Aina Najah binti Muhammad Azlan, me, Nur Farah Kristina binti Mustafa, and Adif Danish bin Muhammad Uznun. First, let me introduce analog and digital system. Analog and digital system are widely used in many electronic devices, including smartphones, computers, television, medical equipment, and communication devices. These systems are responsible for processing, transmitting, and storing information. Although they perform similar functions, they use different methods to process information. Analog systems use continuous signals, while digital systems use binary signals that are represented by 0 and 1. Both systems are commonly integrated into modern electronic devices to provide efficient and reliable operation. I will explain the objective of this report. This report focuses on understanding analog and digital systems by explaining how they work and comparing their main characteristics. It also discusses the advantage and limitation of each system, while highlighting how they are used in everyday life and modern electronic devices.
Okay, let's go to the basic concept of analog and digital signals. Before we go into the deeper explanations about analog and digital signals, it is important for us to know and understand how these signals are used and produced in electronic applications. We have two main types of signals, which is analog and digital signals. These both signals are the basic concept of electronic systems, which carries information from one point to another. Okay, let's go into the analog signal first. Analog signals is continuous signals that most physical phenomena in the real world, such as human voice. Therefore, analog systems such as microphone and speaker were developed to transmit and process these analog signals. Okay, next, with the advancement of technology, digital systems were introduced to more reliable data processing and transmit by using a binary number 0 and 1. In today's modern era, most electronic devices integrate both signals, which is analog and digital signals, where the analog signals are converted into digital signals for processing and converted back into an analog signal for an output. Okay, this is the comparison between analog and digital systems. Okay, the first one is both analog and digital systems are used to present, process, and transmit information. They are widely used in communication, control, and measurement systems, and also susceptible to noise and signal interference during a transmissions. The first difference is the type of signal used. Analog systems use continuous signals, which means the signals can take any values within a certain range. However, digital systems use discrete signals where information is represented by using binary value, which is 0 and 1. The second difference is the waveform. Analog systems are commonly represented by sine wave because the signal changes continuously over the time. However, digital systems are represented by a square wave which switch between high and low logic levels, which is 0 or 1. Another difference is the number of possible values. Analog systems can have infinite numbers of values, where digital systems only have finite number of values, which typically represented by binary digits, which is 0 and 1. Okay, lastly is the example of analog systems included microphone and speaker, which process continuous sound signals. Meanwhile, example of digital systems included computers and mobile communication device, which process information digitally. Based on the pictures above, which one do you think digital systems and analog systems?
Hi, and now I will explain the circuit operation of analog to digital system. So, as you can see here, the block diagram, the operation starts with the input, where analog signal from the real world, such as temperature, light, or sound, are received through a sensor. So, the signal are continuous and cannot be processed directly by a digital electronic system. Okay, the signal is sent to the analog to digital converter, or we call ADC. The ADC, the function is convert the analog signal into the binary data, represent 0 and 1. We can think that the ADC as a translator because it convert the real world analog information into a language that be improve or can understand by a digital data. After that, the digital is transferred to the processor. The processor analyze and process the binary data based on the programmer instruction before preparing the final result. So finally, the final result, the processor's information is sent to the output device such as a LCD screen, speaker or computer monitor where the user can view or hear the final output. Okay, we move on to the right side of the slide. As you can see, also the graph compare analog and digital signal. For analog signal changes continuously with time, while digital signal consists of discrete high and low logic level, represented by binary values 1 and 0. So this conversion enables digital electronic device to process information accurately and efficiently.
For this part, I will explain about the relevant equation and analysis. First, an ADC convert a continuous analog signal into a digital signal. The number of digital level is determined by the equation 2 power of n, where n is the number of bits. For example, an 8-bit ADC provides 2 power of 8, which equal 256 digital level. Next is ADC resolution. The resolution is calculated using the equation Vref over n. If the reference voltage is 5 volt and the ADC is 8-bit, the resolution is approximately 90.5 millivolt per step. A smaller resolution means ADC can detect smaller change in the input signal, resulting in higher accuracy. The digital output is calculated using the equation D equals V in over Vref times 2 power of n minus 1. For example, if the input voltage is 2.5 volt and the reference voltage is 5 volt, the digital output is approximately 128. For DC circuit analysis, we apply Ohm's law, which is V equals to IR, to determine the relationship between voltage, current and resistance. DC voltage provides stable logic levels used in digital system. Finally, noise immunity measures how well a digital circuit can resist electrical interference. It is represented by the high and low noise margin calculated. NMH equals to VOH minus VIH. The larger noise margin improves signal reliability and reduces the chance of error used during digital communication. That's all for my part.
Now, let's look at the advantages of digital system. The first advantage is that digital systems are simple to design because they only use 2 logic levels, which are high and low. This makes them easier to develop, implement, and maintain. Secondly, digital systems provide high accuracy and precision. They can process, store, and transmit data with very little information loss, and their accuracy can be improved by increasing the number of binary bits. Another advantage is that digital systems are resistant to noise and interference. Even if noise affects the signal during transmissions, the original signal can usually be regenerated. In addition, error detection and correction techniques help ensure reliable data transmissions. Digital systems are also highly reliable because they are less affected by aging and environmental conditions, allowing them to operate consistently over a long period. Finally, digital systems are flexible and scalable. They can easily be reprogrammed to perform different tasks without major hardware changes, making them suitable for many applications, including consumer electronics and industrial automations. Despite these advantages, digital system also has several limitations. The first disadvantage is their higher complexity and cost. Digital systems require additional components, such as analog to digital converter and digital to analog converters, when working with real-world analog signal. Secondly, digital systems may experience processing delays because time is required for signal conversion and digital processing. Therefore, they may not always be the best choice for applications that require an immediate response. Another limitation is higher power consumptions, especially in high-speed processing or applications involving large amount of data. Finally, digital systems are affected by quantization error. Since continuous analog signal must be converted into discrete digital values, small difference between the original and converted signal can reduce accuracy slightly. Next, let's discuss the advantages of analog system. One major advantage is that analog system can represent continuous real-world signal directly, such as sound, temperature, and light. This allows them to reproduce signal with high fidelity. Another benefit is that analog systems do not suffer from quantization noise because they do not convert signal into discrete values. Analog systems also have low latency, since they process signal directly without analog to digital or digital to analog conversions. This made them suitable for real-time applications. In addition, analog circuits are relatively simple for basic functions, such as amplifications and filtering. As a result, they often require fewer components and lower costs. Lastly, analog systems provide very high resolutions because they can detect even very small changes in the input signal. This made them ideal for scientific instruments and highly quality audio equipment. However, analog systems also have several disadvantages. The first disadvantage is that they are highly sensitive to noise and interference. Any external electrical noise can affect the signal quality, and the noise is amplified together with the desired signal. Secondly, analog systems have limited capability for complex signal processing. Advanced functions usually require more complicated circuit design and additional hardware. Another limitation is data storage and reproduction. Over time, stored analog signal may lose quality, and every copy made from an analog signal introduces further signal degradations. Finally, analog systems have limited flexibility and scalability. They are usually designed for a specific purpose, and adding new functions often require significant hardware and modifications.
Hi, I am Ratu Shakira binti Muhammad Sabudin. In this section, I will explain the real-world application of analog and also the digital system. These systems are widely used in various sectors to measure the signal, to process the data, and also to transmit the information. So, firstly, in healthcare monitoring system, devices such as ECG monitors and also the pulse oximeters use an analog sensor to detect the continuous psychological signal from the human body, including the heart rate, body temperature, and also the blood oxygen saturation. These analog signals are then converted into digital data using an ADC, allowing the digital system to process, store, and analyze the information for real-time monitoring and better healthcare service. Secondly, the communication and wireless systems such as 5G networks and IoT technologies rely on both analog and digital system to exchange the information efficiently. Analog components collect the physical signal from the environment, while the digital system process then transmit the data, enabling the faster communication, improve the connectivity, and also the real-time interaction between the devices. And lastly is the smart home and consumer electronic system also use an analog sensor to collect the environmental information such as the temperature, light intensity, and also the movement. The collected data is then processed by using the digital system, including the microcontroller and also the embed platform, to control the automate function and enable the remote monitoring. Overall, the integration of analog sensing and also the digital processing plays an important role in improving the performance, reliability, and also the convenience of modern technologies.
Finally, I will conclude this presentation. The objective of this report have been achieved by explaining and comparing analog and digital system, including their characteristics, advantages, limitations, and applications. From this discussion, we can understand that both systems have different functions and widely used in modern electronic devices. Overall, this report provides a better understanding of how analog and digital systems support many technologies that we use in our daily life.
That's all from us regarding the analog versus digital system in daily life. Thank you for watching and thank you for your attention. Bye!